I'll give you guys the beefier one and then we'll exchange them.
This one is transparent, right? So we see the gears up there.
Okay, so basically what you can see is there's a circuit inside. And what the servo is it's an actuator. So it is used to move stuff. For example, we can use it to move something like a control surface of a plane, or for example, the control surfaces of the space shuttle. Those are hydraulically actuated, but say we are building a small model space shuttle, then we won't have the space for hydraulics, we can use something like a servo. So there's, the nice thing about the servo is that we can accurately control where it goes, so we can precisely tell it, I want it to go to this angle, and then it will move to that angle. And the way it does that is that it has a circuit inside, and this circuit knows at all times, knows the position in which the servo is in.
Okay, that's the same one, but bigger.
So it knows this position with a potentiometer, which basically just has a different resistance depending on how much it's turned. So depending on how much it's turned, have you guys seen this one already? Look at the beefier servo. This is the one we use in our space elevator. Right, so a potentiometer has a different resistance depending on how much you turn it. And that way we can basically tell which position the servo is in right now. And then we can give, through our code, we can tell the servo, okay, we would like to have this angle. And then it can calculate how much it needs to spin to get to that position. It spins using a DC motor, so just a regular motor that spins, that has an axis that spins. And then through some gears, we achieve the rotation or we want to achieve. Yes, exactly. So we have position feedback with the sensor, that's the potentiometer, which kind of just tells us, okay, this is how far we've turned already. So we can at any time know the position of our servo and how much do we need to turn it to reach a certain angle. Right, so far so good. Does anybody have any questions as far as it comes to that? No? If you guys have any questions, as yesterday, just let me know. I'll try to answer as much as I can. Okay, anyways, right. So that's what a servo is. In essence, it's an actuator that we can control using these three cables. Yeah, pretty much. Alright, perfect. Right, so use cases, for example in cameras, if we want to move the shutter, robots use servos quite a lot, so that might be interesting for some of you guys that want to do robotics. So we can, for example, we can make an arm and have an arm on this arm here, so this spin. We can spin it by hand, but obviously spinning it by hand is not the way we want to do it, so we can attach it to our microcontroller and it will spin using the DC motor inside. So for example, we could have an arm on this and then have another arm here. So we could have sort of like an arm with two joints, like we have our arm which has a joint here and a joint here, and a joint here. We could have this servo, for example, move this here, so if this servo moves up, then my arm moves up, and then we have a second servo here which moves my elbow, right? So we can make robotics with this. We can make complex stuff that looks like humans and moves like humans. We can also make simpler stuff. So for example, just an arm that drives over here, picks something up, that drives over there, and releases it. Right, and elevators also use servos, and I guess that's the perfect kind of transition into how we use them. In our case, these servos here will be used to brake. So they will push against the wheel like this, if I'm not mistaken, if they're in place and we don't slide up or down the road.
You know a car brake, right? You have the disc and it grabs the disc of the car, so it brakes, right? So we kind of do the same thing, but it moves against the wheel to brake. So you have traction there, and then it brakes. Right, so that's what we use the servo.
So in a normal car, obviously you use a disc that's attached to the wheel because you don't want to brake against the wheel. It's not as, let's say, safe or not as reliable. And if the disc breaks because you wear it down, so you use it too much, you can just exchange the disc, you don't have to exchange the entire wheel. But for our purposes, braking against the wheel is perfectly fine. Because we just need a little bit of braking force, we don't need to brake an entire car that's going at 80 kilometers an hour or something like that. Right. Okay, so that's the